Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. And in this lesson, we will discuss all these questions in detail so you can improve your conceptual understanding and also you can have better understanding of these concepts. And today's video is the first video on AP Physics 1. A lot more videos are coming very soon. So if you're studying for AP Physics 1, you can also go through AS Physics paper 1. You can also find a lot of multiple choice questions in Cambridge AS Physics paper 1, and those questions and AP Physics papers, they are quite similar. If you go through paper 1, AS Physics paper 1, those questions can help you to improve your conceptual understanding, and also they can help you to prepare for AP Physics 1 and also for AP Physics 2. On my channel in future, I'll be uploading a lot of solutions for AP Physics 1 and AP Physics 2. And also, if you have any questions, you can leave your questions in comments and I'll be answering as soon as possible. I will also create a Facebook group for more discussion. So you can also join that group to ask more questions and for extra help. Let's study together. Let's improve together. In today's lesson, we will discuss section 1 of AP Physics 1 exam. Section 1 only contains multiple choice questions and total time for this exam is 90 minutes and there are total 50 questions and this is 50% of total grade. You can use calculators in this exam and also there are two types of multiple choice questions. One is single select questions and multi-select questions. On the second page, you can also find a sample question with sample answer. For example, for this question, answer is B. So this is how you need to fill on the answer sheet. This oval, you have to fill this one completely. But if you change your mind, first of all, you fill B, then you thought maybe answer is D. So you have to completely erase this one and then you will fill this one. So these things are very important to answer in your exam. And for this exam, multiple choice scores are based on the number of questions answered correctly. It means you can guess. Points are not deducted for incorrect answers and no points are awarded for unanswered questions. So it means it is very good if you try to answer all the questions. If one question you don't know the exact answer, but you can use elimination method, you can eliminate, then you can find the best possible answer. So try to answer all the questions. Don't leave any question blank because if you don't answer question, you will not get any marks. So it's better to answer all the questions to get higher grades because points are not deducted for incorrect answer. So it's better try to answer all the questions. On next page of your exam paper, you can also find values of some constants and also some units and the symbols are given to you, prefixes are given to you and values of trigonometric functions for some common angles are also given to you. So if you need value of any constant or you need any unit or you need value of any trigonometric function, you can come to this page and you can find those values. On the next page of your exam paper, you can also find some important formulae. Almost all the formulae you need for AP Physics 1, they are given to you on this page. And some formulae are not given. Those formulae you need to remember. But almost all the main formulae are given to you on this page. So here you can find all the formulae for mechanics. Here you can find for electricity. You can also find some formulae for waves and also some formulae for geometry and trigonometry are also given to you. So if in the exam you have forgotten any formula and you need that, you can come to this page and you can check because it is very important to know that these formulae and constants, they are given to you. And if you need them, you can find them. For this exam, we can use value of g equal to 10 meters per second in all problems to simplify calculations. And it is also given to us each of the questions and incomplete statements is followed by 4 suggested answers or completions. Select one that is best in each case. Means these questions are single select. First 45 questions, they are single select. And then fill in the corresponding circle on the answer sheet. So you have to fill these answers on answer sheet as well. So very important one. Now let's start working on question number 1. For question number 1, it is given to us an object is thrown horizontally to the right of a high high cliff with an initial speed of 7.5 meters per second. Which arrow best represent direction of the object's velocity after 2 seconds? Assume A resistance is negligible. Very nice question on horizontal projection. So the best way to answer this problem is, first of all, we can sketch. Imagine that this one is the ground, so simply we can imagine this one is the ground, and in this case we projected this object horizontally. So it will follow this path. It will go like this. And in this case, there is no A resistance. So there is only one force acting on this object, and that force is force of gravity. So only force of gravity is acting on this object. So we can divide this motion into two parts. We can say horizontal motion. So the best way to answer projectile motion problems is you can separate horizontal and vertical motion. You can treat these two motions separately. So that's the key concept. So we can write on horizontal and we can write on vertical. Horizontal motion in this case will stay constant because there is no force acting along horizontal. It means horizontal acceleration in this case is equal to 0. So we can write down in this case the horizontal velocity. We can say Vx. This will stay constant and its value will be equal to 7.5 meters per second, and this will be to the right. For vertical motion, we can also take initial velocity. Initial vertical velocity is equal to 0. So we can also write down here ux, because initial horizontal velocity and final horizontal velocity, they are the same because there is no acceleration. And also in this case, time is given to us after 2 seconds. So time is given, we have 2 seconds. We can find the v final after 2 seconds. So we can find out v final. And along vertical, acceleration is given to us. That is equal to 10 meters per second, and direction of acceleration is down. So we can use these informations and we can find value of v. So v will be equal to uv plus at. And we have initial velocity that is equal to 0, and we have acceleration that is vertically down. So we are taking vertically down as positive. So very important, you need to take one direction as positive. So value of A will be positive because this is down. So we can also write one positive sign here. This will be positive because we are taking down is positive. And times, we have the time that is 2 seconds. So it means the final vertical velocity, we have 20 meters per second, and this is vertically down. So this is value of final vertical velocity. The question is asking us to find direction of object's velocity. So this object has two components. One is horizontal and one is vertical. Horizontal component is to the right and vertical component of velocity is down. Vector sum of these two velocities is the final velocity after 2 seconds. Vector sum of these two velocities. So the best way to answer this problem is simply we can use arrows. So we have this horizontal velocity, this is 7.5. So simply we can draw this is 0.7, 0.8. Simply for simplicity, we can say this is 0.8. And we have vertical velocity that is 20. So we can draw this is 2 centimeters. So this one is 2 centimeters. If you divide by 2, so this is 2 centimeters. So this one simply I can draw. This is 2 centimeters. Now what is the final velocity? Final velocity is the vector sum of these two. So this is the final velocity. So this one is final velocity. This is the final velocity. Now we need to compare this arrow with the given arrows. If you look at option A, this is 100% not possible, and this option is also not possible because this is around 45, but this is more than 45. So we can also ignore this one. This is also not possible because this is telling you object final velocity is vertically down, but final velocity is not vertically down. So this angle, if we find this angle, this has to be more than 45 degrees. This angle has to be more than 45. We can also find this angle. If you're curious about this one, you can find this angle. So this angle we have, this is 20 and this one is 7.5. So we can use tangent of theta. You can also find out value of this angle. So this will be 20 divided by 7.5. So the theta we can find out from here. We will have tangent inverse 20 by 75. We can use calculator and we can try to find out its value. If we calculate value of this angle, we will get angle is equal to 69.4 degrees, and that is greater than 45 degrees. So the answer for this question is C. So this is how you can approach this type of problem. Try to understand concepts, so next time you can use these concepts to answer other same type of questions. For the second question, we have velocity against time graph. We have velocity on y-axis and time is given on x-axis. We need to find out which of the following correctly ranks the change in kinetic energy for each segment from least to greatest. And change in kinetic energy, this one can be positive, now this one can be negative. If the speed is increasing, change in kinetic energy is positive. If the speed is decreasing, it means change in kinetic energy is negative. As in this case, mass is constant, so the change in kinetic energy simply we can determine based on change in speed. So let's try to find out how we can approach this problem. First of all, we can draw these dotted lines so we can read the speed from y-axis. We can simply, this is about at the meter. We can also draw one dotted line from here so we can easily read from the y-axis the speed. And for the last one, we can also draw, this is about 2. So now we can write down the change in speed. For first segment, delta VAB, the change in speed is positive, and that is 7 meters per second, means the speed increases by 7 because this one is 7. And this one is 3 here, and this is 2. And for the second segment, for delta V, BC, change is 0 because there is no change in speed. So we can say this is 0 meters per second. And for the next segment, we have delta VCD, change is minus 4 meters per second, meaning the speed decreases by 4 meters per second. And for the next segment, delta VDE, change in speed is negative because the speed is decreasing. And for the last segment, we have delta VEF. The change in speed, this is negative. It means speed is increasing. Speed increase from 0 to 2. So we can say this is plus 2 meters per second. Now we need to find out least. So which one is the least? So we can start first of all, which one is the least? So this one is the least. So we can say this one has to be first. So this one has to be first. This one is the least. And next one is this, and next one is this, and next one will be this one, and the last one is this one. So based on this one, we can find the answer. First one has to be CD. So if you look at given options, CD is only here at the first. So it means our answer for this question is D. So we have CD. So the first one is CD. First one is CD. Second one is DE. And third one is BC. Actually, they have flipped this one. BC has to be here. BC has to be here, and EF has to go here. So this is, they have to flip this one. So fourth one is EF. So this is EF, and the last one is AB. So the answer for this question is D. So this is how we can approach this problem. For the next question, again, we have the same velocity against time graph, and we need to find out during which segment is the magnitude of average acceleration greatest. So simply we need to look at the gradient of these segments, because gradient of VT graph is equal to acceleration. So we can say gradient of VT graph, this is equal to acceleration. So we can write down this is equal to acceleration. Now we need to compare these gradients. If you look at gradient of segment CD, this seems like it's the steepest one. But still we can compare AB with CD because the gradient of DE and EF is much less steeper than CD. So we no need to compare with these parts, but we can compare gradient of AB with CD. In order to compare, we can draw first of all this vertical line, so we can easily read these values. We can also draw one vertical line from here, and we can draw one vertical line from here. Now we can calculate gradient. For segment AB, we can write down acceleration AB. This one will be equal to the final velocity, that is 7 minus 0 divided by time. Time is 3 minus 0. So we can find the value, that is 7 by by 3 meters per second in this case. We can also calculate for segment CD. For segment CD, we have the final velocity that is minus 3 in this case. This is plus 3 because you can read from here. So we can read from here. This is plus 3. So we can simply read from here. And the initial velocity we have, this is minus. In this case, we have minus. Initial velocity we have, that is 7. And this is divided by time taken. Time taken in this case is only 1 second. 1 minus 0. So we have, in this case, this is minus 4 divided by 1. So simply we can say this is minus 4 meters per second per second. So in this case, simply we need to compare the magnitude. As 4 is greater than 7 by 3, so it means the answer for this question is C. So this is how you can compare. For question number 4, we need to calculate the total distance traveled by the object. And we need to understand distance is a scalar quantity and it does not depend on direction. So distance will not be negative. So distance is always positive. We need to calculate total distance and VT graph is given to us. So simply area under VT graph represent distance. We can say area under VT graph represents, we can also write down area under VT graph. This represents distance traveled. So is distance traveled. Now we need to calculate area under this graph. In order to calculate area under this graph, simply we can draw these lines. We can divide this one into different parts and then we can calculate total area. So we can divide this one into rectangle and this one is trapezium and this one is triangle and this is also triangle. So this line we can draw and this is about, actually I said before it was 2. So we need to calculate these areas now. So the total area in this case, simply we can say total area, or we can say the total distance travel. So we can simply write down this distance travel. This one will be equal to area of this triangle, and area of this triangle is 1 by 2. 7 times 3. So this is area for this triangle. Next area we can also calculate this area. This one is a rectangle and area of this one will be 7 times we have 2. So we can calculate area. And this is trapezium. We can calculate area of this trapezium. So we can simply take, in this case we have 7 plus 3 divided by 2 and we can multiply with this. So this is 1. And next one we have triangle. For triangle we have, this is 1 by 2 and we have 3. This is the height of this one. And here we have 9 minus 6. It means 3 is here. Plus, we also have to plus this area. This is the main point you need to understand. This one you have to plus. This one you have to plus. And this area is about 2 actually. So we will just take this one as a 2. I mean this side is 2. So we can write down this is 1 by 2. And this one is 2. And this is also 2 because 9 to 11. So we have 2 times 2. Now we need to add all of them. So this is 7. 7 times 3 means 21. 21 divided by 2, it means this is 10.5. So we will get this one is 10.5 because this is 21. Plus we have 14. And here we have 10. 10 divided by 2, 5. So here we will get 5. And here we will get, this is 9. So divided by 2, we will get 4.5. And 2 we can cancel with 2. So we have 2 here. So in this case, we have, this is 10.5 and this one is 4.5. So we can have this 11 plus 4. So this one is 15 plus we have 14 plus we have 5 and plus we have 2. So 14 plus 15, this is 29. 29 plus 7, we have 36. So the total distance traveled is 36 meters. And this is about 2 actually. So we just took this one as 2. So this is about 2. Let me redraw this one. So let's redraw this one. So this is about 2. So if we draw from here, this is about 2. So that's the reason we have taken this one is 2. So the answer for this question is C. So C is the answer. For question number 5, it is given to us a ball is thrown in a projectile motion trajectory with an initial velocity v at an angle theta above the ground. If the acceleration due to gravity is negative g, which of the following is the correct expression for the time it takes for the ball to reach its highest point y from the ground? So this is a typical question about projectile motion. So the best way to answer this problem is we can sketch. Otherwise we can just use this given sketch. So in this case, we throw this ball at velocity v and at an angle theta. So when it will reach the maximum height, let's say it reached this point. So this is the maximum height. After that, it will start moving downwards. So this is trajectory of this projectile. So this is trajectory. You can use dotted line here. So this one is over ground. So this is the ground. So in this case, this is the maximum height. And maximum height in this case is given. That is equal to y. So we can also draw this dotted line here, and we can say maximum height in this case is y. We need to find expression for time. And at maximum height, we need to understand Vy will be equal to 0. So at peak point, we can also write down Vy. This one will be equal to 0. And in this case, we have to take A is equal to minus G. It simply means that we are taking, in this case, upward as positive. So we are taking upward direction as positive. We have initial velocity. We can say in this case, initial velocity is V, and initial velocity, this is vertically up. So we are talking about vertical motion. So very important point. So I will be writing here vertical motion. We are talking about height. So we will take vertical motion. We will take UV. UV in this case is V. If we resolve this one into two components, we can resolve this one into two components, horizontal component and vertical component. We are talking about vertical motion. So we have to take this component of motion we have to take, and this component of motion is vertically up. And as this angle is theta, so this component is V sine of theta. So we can say in this case UV, this is equal to V sine of theta, and this one is vertically up. So this one is positive because we are taking up is positive. Now we need to find out expression for velocity and the final expression for time, and the final velocity in this case is 0. So we can say Vy is equal to 0. We have also value of A is equal to minus G, and we need to find out expression for time. So simply we can use V is equal to U plus AT. V is equal to U plus AT. So this equation gives us time because we have initial velocity, we have final velocity, we have A. So simply we can use this one. So final velocity is equal to 0. And the initial velocity is V sine of theta. A is equal to minus G times time. We need to find time. So we can write on GT in this case. This will be equal to V sine of theta. And we need to find time. So this will be equal to V sine of theta divided by G. So this is the expression for time. And now we look at given options and we can find the answer. If you look at given options, answer for this question is C. So C is the right answer.